past 9, 10. So now today is the 6th day of myself doing the revision for semester 1 examination. Today is 9th of November. In the previous class, I remember I had done number 5, a problem based on calculation of the percentage composition. Okay, that is which is there in the syllabus. Okay, now today I'll continue revision for this semester 1 only. Okay, now please, if possible, please pay attention. So I'm writing down the question for you all. Okay, on your screen, question number 1 for today. The chapter's name, mole concept and stoichiometry. Stoichiometry. That is the chapter's name. Okay, and today's problem number 1. A compound made up of two elements x and y has an empirical formula x to y if the atomic weight of x is 10 and that of y is 5, and the compound has a vapor density 25. Okay, what is its molecular formula? So options, I'm writing down the options. Option A option A is x 2y. Option B x 3y 2. Option C x 4y 2. Option D xy. Okay, so huh?
4y2.
x4y2 is the correct answer. That is the correct answer. But what about the working? There's a compound made up of two elements x and y. Its empirical formula is given x2y. So, and its atomic weight of x is given 10. 10 to the 20, 20 plus 5, 25. 25 is the empirical formula mass. Okay, and its vapor density is given 25. So its molecular weight will be 50. 25 into 2 is 50. So 50 divided by 25 is 2. So that is the factor. So you have to multiply that factor n, and the value of the factor n is 2. So you have to multiply this 2 to the empirical formula. Okay, that empirical formula is x2y, and outside you have to put over here 2. So it becomes x4y2. That is the correct answer. Okay, if you want to know the working, I'll do the working also. How to work or do the working? Let me show you. For this sum, this is how you have to do the working in a rough. Empirical formula mass of x2y is equal to twice into 10 plus 5, that comes to 25. and molecular mass of the compound. Molecular mass of the compound will be twice into vapor density, and vapor density is given as 25. So that comes to 50. Okay, so we know the empirical formula mass 25, we know the molecular mass, that is 50. So based on this empirical formula mass and molecular mass, we can get the factor n, small n, which is obtained by dividing molecular mass divided by empirical formula mass. So that becomes 50 by 25, that is equal to 2. After that, therefore, finally, you can write down, finally, molecular formula is equal to, empirical formula is x2y, open the bracket, outside you write down 2. So put the 2 inside, you get x4 y2. So this is how you get the working. Okay, this entire thing can be done mentally if you think properly by concentrating and work out mentally. You can get the answer. Okay, so this was number 1, the first sum for today, number 1. Okay, complete, try to go through it carefully. Okay, if there are any questions, please ask. Okay, yes,
Sir, can you please show me the question?
I'll show you the question. I'll show you the question. Just a second.
Sir,
Just a second. Just a second. Wait. Yeah. The question is here. Yeah. Question is here on your screen. A compound made up of two elements x and y has an empirical formula x to y. Full stop. If the atomic weight of x is 10 and that of y is 5, and the compound has a vapor density 25, what is its molecular formula? Okay, so that is the question. Options are given: x2y, x3y2, x4y2, xy. So you have to choose the correct answer for its molecular formula. Okay, is that done, my dear boys?
yes, sir.
Okay, wonderful. Shall we go to the next type? Next problem? Yes, my dear boys. Number 2.
Yes, sir.
Okay, so we move to the next question. That is number 2. Okay, let me write the question on the screen. Okay, let me write the question on the screen. That is number 2 for today. The question is like this: a compound contains a compound contains 88.89% oxygen, and rest is oxygen. Rest is hydrogen. Okay, full stop. So they are saying calculate its empirical formula. Calculate its empirical formula. That is the question. Okay, the atomic masses are given. Hydrogen it's 1, oxygen is 16. Okay, is that okay? So now, to do this sum, you have to do some working in your rough. Now the two elements are oxygen and hydrogen. Percentage of oxygen given is 88.89. Percentage of hydrogen given is, it is not given, so to get the percentage of hydrogen, 100 minus 88.89. So if you subtract this, you will get over here 11, over here also 11.11. So the percentage of hydrogen is 11.11. Now we have to get the what you call relative number of atoms. relative number of atoms of oxygen is obtained by dividing 88.89 by 16, and the relative number of atoms of hydrogen is obtained by dividing 11.11 by 1. This one, okay, and for oxygen 16. Upon simplification, for oxygen it becomes 5.55. For this it becomes 11.11. Now after that, get the simple ratio. To get the simple ratio for oxygen and hydrogen, you have to divide this number 5.55 and 11.11 by a number among these two which is smaller. Among these two which is smaller is 5.55. So divide both these numbers by 5.55. So it becomes 5.55 divided by 5.55 is 1, and 11.11 divided by 5.55, that comes to 2. So this is the simplest ratio of oxygen and hydrogen in the compound. So they are telling us calculate the empirical formula. So empirical formula is OH2, or arrange it properly, it is H2O, that is water. Okay, try to get this, it is very interesting sum. Okay, this you should not be able to do mentally, you have to do a little bit of working has to be done. I'm not showing you the what do you call the table which is required to do this sum, but I'm teaching you a much easier method. Just write the symbol. All right. So here what you have to do is you have to remember this format. Write the symbol of the elements and the percentage, divide the percentage by the atomic mass, okay, and get the relative number of atoms, and then get the simple ratio. Okay. Once you get the simple ratio, whatever the simple ratio, that goes in the empirical formula. Okay, so that is number 2. Okay. I think this is clear to all of you. Any question you have, please ask. Please feel free to ask any questions. Okay, because this is the time to clear your doubts regarding this. Okay, now shall we go to the next question, my dear boys?
Yes, sir.
Okay, so let us go to the next question. That is question number 3. I want to make you perfect in this empirical and molecular formula thing. Okay, so we go to number 3. We go to number 3. The question is like this. Uh, a compound has molecular formula C4H10O, which means what? There are in that compound, there are 4 carbon atoms, there are 10 hydrogen atoms, and there is 1 oxygen atom. Okay. So now they are telling us calculate its molecular formula. Calculate it's not molecular formula, calculate its empirical formula. Calculate its empirical formula. That is the question. A compound has molecular formula C4H10O. Calculate its empirical formula. So, how do you do this? What will be the empirical formula for this compound? The molecular formula is C4H10O. The ratio of the elements are 4 is to 10 is to 1. Can these numbers be further simplified? Tell me.
Yes, sir.
Yes? Do you think you can simplify these numbers further?
Only with one.
Only with 1. So if you cancel all this with 1, what do you get? You get same thing, no? 4 is to
Yes, sir.
10 is to 1. So can I say empirical formula is same? Therefore, empirical formula is equal to same thing, C4H10O. Are you getting it? So in such a situation where the ratios cannot cancel each other into a whole number, that means in such situations, the empirical formula and the molecular formula are the same. Are you getting it? Are you getting it? Yes. For example, if the molecular formula is say C4H8, okay, and I ask you what is the empirical formula. So what will be the empirical formula? If the molecular formula is C4H8, so what should be the empirical formula? Tell me. Do you think you can cancel 4 and 8? Can you cancel? Yes. 4 ones are 4. 4 ones are 4 and hydrogen. 4 twos are 8. So empirical formula is CH2. Are you getting it? Dear boys, are you getting this? How to convert the
Yes.
molecular formula to empirical formula? You should be able to cancel. If it doesn't cancel, then the molecular formula and the empirical formula are the same thing, are the same formula. Am I clear? Be confident, be confident. Okay, answer confidently. Okay, one more example I want to give you over here. Say there is a formula like this, C8H22, okay, O12. If this is the molecular formula and I ask you what is the empirical formula, what will you do? If this is the molecular formula, I ask you this one empirical formula, so how will you do this? They will cancel. Will they cancel?
Cancel by 4.
Cancel.
They will cancel by
Cancel
2,
by.
no? 2 4s are 8, 2 11s are 22, 2 6 are 12. Are you getting it? Will they cancel further? Will they cancel further? Huh?
No, sir.
No, they will not cancel further. So we have the empirical formula C4H11O6. Isn't it? Is the concept of empirical and molecular formula becoming clearer in your mind now?
Yes, sir.
Yes.
Yes,
Now,
sir.
since the concept of empirical and molecular formula is becoming slightly clearer in your mind, now I want to tell you the definition of empirical formula. Okay. Empirical formula, empirical formula is the formula that shows the simplest ratio of atoms of different elements different elements present in the compound present in the compound. This is the definition for empirical formula. So you should remember this, not learn the definition by heart, but remember the definition. How will you remember? Try to generalize it as if we are speaking something naturally. If I ask you, what is your name? You know your answer. My name is so and so. You know, and in a similar way, you should be able to speak this or write it down. Empirical formula is the formula that shows what? Simplest ratio of atoms of different elements present in the compound, present in the molecule of a compound, you can say. Okay, so that is the definition for empirical formula. Okay, I hope that is clear to all of you. Is it clear? Is it clear? Okay, so let's move further to the next question. Okay, so next question. Now this question, that is this was number 2 3, now we go to number 4. Number 4, this question I want all of you to do it, and I'll wait and I'll see your working. Those who do it, you have to share your screen to me. I'll give permission for you to share the screen and or show it to me or by switching on your camera. Okay. So the question is here like this. Please copy it down and do it. Okay. A compound. A compound contains 90, just a second. A compound contains 92.3%. 92.3% carbon, carbon, and and the rest is hydrogen. Rest is hydrogen. Its molecular mass is 78. Its molecular mass is 78. Okay. The question says calculate its molecular formula. Calculate its molecular formula. That is the question. And what is given? The atomic masses are given. Carbon atomic mass is 12. Hydrogen is 1. Okay, so you please do it. Please do it. I'm waiting. Okay, please do it. And then I'll allow you to switch on your camera and show me on the camera you're working. Okay, do it. I'm waiting. A compound contains, copy the question first. A compound contains 92.3% carbon and the rest is hydrogen. Have you copied the question?
The copying.
Yeah, copy it and do it. Okay, you can do it. Okay, first step I have shown you over there. Now try to get the relative number of atoms and then get the simple ratio. First get the relative number of atoms because this is the percentage.
C6H6. So
C6
C6H6.
yeah, correct answer. C6H6 is the correct answer. So get the relative number of atoms and get the simple ratio. Simple ratio. To get the relative number of atoms, divide this 92.3 by 12, 7.7 by 1. So if you divide 92.3 by 12, you'll get 12 7s 84. 12 7s 84. 84 60, 84 62, 12 5 is 60, 12 6 is 72. Yeah. 12 6 is 72. 72. Okay. Then 6 7.6. 12 9 is 108. 9 7.69.
Sir, 9-1.
91. 7.91.
Yes, sir.
Oh, 7.91. This will be 7.7 only. So 92.3 divided by 12. Just check. 92.3 divided by 12.
So it's 7.691.
92.3 divided by 12. 7.691, correct. I think 691 is okay, fine, no problem. Now, to get the simple ratio, so to divide both these numbers by a number which is smaller, no? So you divide both by 7.691. Here also 7.691. So if you divide this will get 1. This also will get 1. So the simple ratio is 1 is to 1. So empirical formula is what? Empirical formula is what? It is CH only, isn't it? Empirical formula is CH only. And we know the molecular mass is given. molecular mass is given. It is given 78. So what is the empirical formula mass? Empirical formula mass is 12 plus 1, 13, no? 13. So work out the factor n. N is molecular mass by empirical formula mass, that is 78 by 13. That comes to 3, 6, 18. It comes to 6 exactly. So therefore, molecular formula is equal to empirical formula. We already know it is CH. CH outside the bracket, we put 6 over here. And now put the 6 inside, we get C6H6. So that is the answer. Okay. Is that clear, my dear boys? Is that clear?
Yes, sir.
Yes, sir.
That was easy, no? I think you are perfect now in this. Yes?
Yes, sir.
Okay, that is nice. I'm happy that you are able to do this conveniently, easily. Okay. So one more sum I'll give you. One more sum I'll give you. Number 5. Number 5. Okay. Okay. So copy this question again and do it just now. Okay. Before the time is up. Okay. Uh, gaseous compound. A gaseous compound of nitrogen and hydrogen. Nitrogen and hydrogen contains 12.5% hydrogen by mass. Hydrogen by mass. Find the molecular formula. Find the molecular formula of the compound find the molecular formula of the compound if its relative molecular mass molecular mass is 37 and the atomic mass is given. Nitrogen, it is 14, hydrogen is 1. Do this now. I'm waiting. Okay, do this. Copy the question. Okay, copy the question and do it.
Hello.
Hello, yes. So we have obtained the simple ratio for nitrogen and hydrogen. The simple ratio is coming how much? The empirical formula is coming how much? N?
Empirical. Nitrogen 1, hydrogen 2.
Correct, NH2. No, it is NH2. And the relative molecular mass. Relative molecular mass is given in the question how much? 37. But we don't know the empirical formula mass. We have to calculate it. Empirical formula mass is 14 plus 2. 14 plus 2 is how much?
16.
16.
16.
16, yes. So, is it NH2? Empirical formula is NH2. And the empirical formula mass, it's coming 16. Okay, that's fine. No.
Body को साड़ी नहीं है सर?
It is given. Okay.
So it cannot divide, no?
No. Just a second. The slight mistake in the question. Relative molecular mass is not 37, it is 32. 32.
Oh,
32, yeah. Here I made a mistake in the question. So N will be equal to, this is 32, okay. N will be equal to 32 divided by 16.
N2H4.
So, therefore, molecular formula is equal to,
2H4.
yeah, NH2 outside 2, it becomes to N2H4, okay. So I expect you all to attempt such questions confidently and get the correct answer and write down the correct option in your semester 1 examination from this chapter, okay. Okay, it is a scoring question, okay. You should be able to do it correctly. So with this I would like to what do you call, end my class for today here only. The chapter is also complete revision, okay. Now in the next class I'll be revising, that is tomorrow. The next revision portion for tomorrow is which chapter, remember, after mole concept and stoichiometry. In tomorrow's class I will revise what do you call,
Electrolysis.
yeah, electrolysis, correct. So I'll revise electrolysis, okay, in my next class. But uh, so just try to go through whatever has been taught to you all from the chapter electrolysis, so that revision work becomes easier. Are you getting it? Revision work becomes easier, okay. Now let me record the attendance so that you can join the next class. What do you have in the next period? What do you have?
Group 3.
Nepali.
Group 3, okay. Group 3 or Nepali?
Group 3.
Huh?
Group
Group
3.
3,
Group
okay.
3.
Okay,
Group 3.
fine. Okay, that's excellent. Okay, thank you so much. Boys, have a nice day.
Thank you, sir.